So given that we have arrays, why do we need linked lists? Uh, it's because though they are used in very similar situations, in arrays, things are kind of static. You allocate a certain amount of memory right at the start, and then if you want more memory, then you reallocate the entire array. That is not ideal. What else? Now, if you want to insert something in the middle of an array, then that is costly. Okay, it doesn't come for cheap. Why? Because you have to make space for that element, and while doing so, you have to move a bunch of elements to the right. The same thing happens when you delete something in an array. You have to uh, fill in that space, the void created by deletion of an element. So that is why we use linked lists. So they can be of dynamic size. So you can have a list that has just one node, and as and when there is a need to add more elements, you can keep adding nodes to the end. Okay. So these are dynamic by nature. And you can insert and delete elements with ease. And you will see why that is the case. Okay. So linked lists are not contiguously stored in memory. Arrays are in a continuous range of memory. So if the first element is at an address of 100 and you are storing integers each of size 4 bytes, then 100, 101, 102, 103. These 4 bytes would go to the first element of the array, which is as index 0. Then index number 1 would begin at 104. Index number 2 would begin at 108. So all the locations in an array are stored next to each other in memory. That is not the case with linked lists. Anytime you need a node, you allocate it using dynamic memory, which in the case of C is the call to malloc. So when you do malloc, a certain chunk of memory is allocated for you to store the node, right? And then you link that node to the linked list. Okay, whether you can put it at the end, you can put it in the middle, right? And after some time you need another node, you allocate more memory. Now that memory may not be in the same region where you allocated the last node. Okay, it can be somewhere else altogether. So all of these nodes are scattered throughout memory, but they are linked using pointers. Okay, they're linked using pointers. So linked lists are dynamic in size. You can increase or decrease their size without much of a cost. You can also easily insert or delete nodes from linked lists without having to move elements around like you did in arrays. Okay. So you do not waste any memory. So you do not have to pre-decide the size of a linked list. You can, just like you have to do for arrays. For arrays, you have to say, okay, I need a maximum of 100 elements in the array. Though you'd only use like 10, you still had to, to be on the safe side, you allocated 100 elements. 90 of those were never used. But that's a lot of memory to waste. In linked lists, you don't do that. Whenever there is a need to store one element, you just allocate memory for that one element only, one node. You need another one. At that point, on the fly, you allocate another one. So there is no memory that you waste. And you have efficient insertions and deletions. We already discussed this. But what are the disadvantages? Like you have memory overhead. What links elements in an array? Like I have one element, the other element. What links them? When you are at one element, how do you know how to go to the next one? Can someone tell me?
Pointer.
No, there are no pointers in arrays.
Oh.
In an array, let's just say you are at one element. Right?
So they are stored next to each other.
Exactly. So they are stored next to each other. So if you're at element n, and if you know the size of one element, then it's very easy to go to the next element. You basically just add those many bytes to the address of that element where you are at, and you will get the address of the next element. So you don't have to store any extra piece of information to be able to go to the next element. But in the case of linked lists, you have to store that extra piece of information that will help you go to the next node. So you store two things. One is the data that the node stores. It can be an integer, a float, or a structure, or whatever that you're storing. That one kind of thing that the linked list is supposed to store. It also stores a pointer and address to the next node. So you use that pointer to be able to go to the next node. Once you are at the next node, you can use the next pointer to go to the next node. At some point, that next pointer points to null, and then you have reached the end of the linked list. We will see all of that very clearly going ahead in this class. Access type. Okay, you cannot directly access elements in a linked list. What does that mean? If I wanted to go to the fifth element of an array, and I know where the array begins, it is very easy for me to go to the fifth element, right? Just like Yuvraj said, we know the sizes of each element, and we can just multiply the size of one element with where we want to go to, the index, and we will get the address of that element. You can directly go there. You can randomly access elements in an array. But in a linked list, they are not stored according to any pattern. The elements can be anywhere in the heap, which malloc help you. Can kind of get those nodes, give you the addresses, but that's all random. There is no pattern to it. So you cannot go to the fifth element of a linked list without going through all the first four elements. You always start at the beginning, then you go next, second element, next, third, next, fourth, next. So you kind of go through all the n-1 elements to go to the nth element of a linked list. And there is no cache locality. Any questions so far? Okay. We'll try to keep the class short. I don't want to burden you with a lot of information on linked list. People usually find this topic very challenging because this is their first real exposure to data structures. I mean, arrays kind of everyone knows from whatever they've done in the C programming classes. But linked list is their first, it's their foray into data structures. Right? So I'll keep it short so that it's easier on you. Okay, all right. So no cache locality. What is the cache? It is something that sits between the processor and main memory, right? Processors are usually very, very fast. Main memory, not so much. So you put some kind of memory in between processors and RAM so that you can prefetch certain things and keep it in the cache. When the CPU needs something, what will it do? It will first go check in the cache. If it is there, it will quickly get it. Otherwise, if it's missed in the cache, it's not there in the cache, it goes to memory and gets it. It takes a little longer to do that, but still, that is what the cache does. But there is no locality like in arrays in linked lists. What do you mean by that? In an array, if I fetch the first element, what can the CPU do or the cache do? It can also prefetch the rest of the elements, like from the next 10 elements and keep it in the cache. Maybe we need it. Usually, if you need the first element, don't you also need the second, third, fourth usually when you write a loop? Yes or no? You usually do that.
Yes.
Right? Yeah.
Yes.
So if it's already in the cache, then you can quickly get it. Why? Because all the elements in the array are next to each other. If I'm getting something at address 10, then the cache might go and get address 11, 12, 13, 14, 15, all the way till 20. So many of those nearby array elements will be in the cache just because you accessed one element. But for linked list, you cannot do that because there is no pattern. You access something at address 10, but the next node might be in address 2000. The third node might be in address 10,000. They're all scattered. So that performance benefit you will not get in linked lists. Okay, so in our class, in this course here, we will discuss 4 kinds of linked lists. The first kind is a singly linked list. So here you can see there is a linked list. The first node is usually called the head, and the last node is usually called the tail. That's all. There is nothing special about these elements, except for the fact that no one is pointing to head, and the tail is pointing at nothing. Right? No one is pointing to head, okay, and the tail is pointing to null. Okay, that's the only thing special about these nodes. As you can see here, node 1, which happens to also be the head, has integer 20 stored inside it, and here in the space here, it's a pointer. 2 things stored: data and the pointer to the next node. Pointer as in the address to the next node, and that points to the second node. The second node here has 40 stored inside it, and that is pointing to the last node, node 3, or the tail. And that has 60 stored in it, and that does not point to anything. It points to address 0. Right? Does this make sense? It's a simple thing. Yes.
So what is considered next in this list? Like the pointer to the next node thing.
This area here.
Okay.
Okay. Yeah. And this will become clear when we look at the code. Right? So this is just a representation of a singly linked list. Now, the problem here is that you can only move in one direction. You can go from node 1 to node 2. But if you are at node 2, you cannot go to node 1. Why is that? Can someone tell me? Why can't you go from node 2 to node 1?
Sir, because the position of first node is lost.
Correct. There is no information in node 2 that points to node 1. Node 2 here has 2 pieces of information: the value and the next pointer. The next pointer points to the next node. There is nothing that points to the previous pointer, that points to the previous node. There is no pointer here that points to the previous node. So if you are a tail, you cannot go to node 2 or node 1. But if you are at node 2, you are able to go to the tail. Right? You can only move in one direction, not in the backward direction. That is where doubly linked lists come into the picture. You can see this is the head, this is the tail, and this is some intermediate node. Each of these nodes in this doubly linked list have 3 pieces of information: the next pointer, the previous pointer, and the data. What is special about the head is that it points to null in the backward direction because there is nothing before it. What is special about the tail is that it points to null in the forward direction. Okay? And they're all linked in both directions. Like, from the head, you can go to node 2 using the next pointer like this. But if you're at node 2, you can also go back to node 1 using the previous pointer like this. Is this clear? Hello?
Yes, sir.
Okay. Cool. Then the third kind is a singly linked circular list. Now, this is like very easy to understand because, as you can see, this is a singly linked list here, right? From head to node 2 to node 3 to tail. Okay? For a linked list, the tail points to null. But if we just make it point to the head, won't this become a circular list? Right? The tail points back to the head. Okay. Tail does not point to null. It just points back to head. So it becomes a singly linked You can only move in one direction, but it's a circular list. This list has no end. Okay. And what about the doubly linked circular list? It's a doubly linked list. But the tails next is head. Instead of the tails next being null, it is pointing to head. And the head's previous, instead of being null, is pointing to the tail. Okay. So the head's previous, here, as you can see, the head's previous was null. But if I make it point to the tail here, and the tail's next, instead of it being null, if I make it point to the head, won't it become a circular, doubly linked list? It will also become circular. You can move in both directions, but it's kind of circular. All right? Does this make sense? So this is how you define a node for a singly linked list. You probably know what's a type def. It's a type definition, right? So we are defining this type and we're calling it a node. We're giving it a name so that all the time we don't have to write struct node. We can omit the struct keyword by just defining this entire thing from here to here as a type of its own, and we give it a name node. So next time around, we can just refer to the entire type as one identifier, as one type whose definition is given here. I think most of you who did C programming know this. And each node structure as an integer, the data that it stores, I mean the linked list stores something. Otherwise, why do you have a list if it is not storing anything? It's pointless to have a list not storing it. And what else is there? There is a pointer. Why is it a pointer? Because you have this. Okay. This is a pointer to the next node. Okay. This is not a circular reference. If I remove this asterisk, will it work? I mean, is it even valid in C to be able to define a struct and have itself as a member inside the struct? If I just remove this asterisk, is that possible? I mean, while defining node, I have a node inside that. Just for the time being, ignore that this asterisk is there. That is not possible. Why? Because of circular reference. You're defining node, and inside that you have something called node. What is that node? You have to go inside node, but there is another node. So you just go inside this endless, abysmal thing, right? Not able to figure out what node is. Because node needs the definition of node. But there is no end to it. Can you understand that? It's called a circular reference. Okay? That is not going to work. But this will work. Why? Because this is not node. This is a pointer to node. This does not need the definition of node to work. It is just an address. It is pointing to another node. This does not need the definition of node to work. You can do this, though you cannot do this. If you remove the asterisk, that is not going to work. Is this clear? Or what I'm trying to say here?
Yes, sir.
Okay. So what exactly is happening here is that, so we have this node structure. This is this one node that you see here. This node. Okay. It contains some kind of data. You can have a character, you can have a string, you can do whatever you want. You can store another structure here. For simplicity, I just have one integer here. Okay. And there is a pointer to another node. That's all. Okay. It's a pointer because we have an asterisk. Now let's go through some around 9 or 10 basic operations and then I'll stop today. Creating a new node. How can you create a new node? So you can do something like this function here. You can do what this function does to be able to create a new node. To be able to create a new node, what does your function have to return? A pointer to that node. Why does it have to return a pointer to that node? It has to tell you where it created the node. If you don't know the address to the node, how can you then manipulate that node that got created on the heap? Right? All of these nodes are created on the heap. And what helps you with that? The malloc function. Right? So the function has to return the address of the node it created so that you are able to go there and manipulate the node. How will you manipulate the node? Maybe you can give it a new data. Whatever data is there in the node, you might want to change that. What else can you do? You can make it point to another node. In that case, you will go and change the address inside that node. To be able to do all of that, you need to know the pointer to that node. Okay, not just a copy of that node. You need exactly where the node is. That is why this function returns a pointer to the node that it creates. Is this clear?
Yes, sir.
Okay. And what does it take? It takes this data, right? It takes data because that is what you will put inside the. What is happening in this line? So we are trying to allocate some memory using malloc. How many bytes? Whatever is the size of this node structure. Okay. What do you think is the size of this on a regular computer that uses 32 bits of memory? So it's a 32-bit machine. So ints are usually 32 bits, 4 bytes, and addresses will also be 32 bits. So this is going to be 4 bytes plus 4 bytes, 8 bytes of. This is true for 32-bit machines. For 64-bit machines, it can be different. We don't care. We just use size of, and then that gives us the size of a node on your computer. And then we allocate those many bytes on the heap. What does malloc return? It returns a void pointer. It is important to cast it to a node pointer. It is important for you to do that because its void is a generic pointer. It can point to anything. If you cast it like this, then it is assignable to some variable like this. So what is this? New node? New node is a pointer to a node structure. Mark my words. New node is a pointer to a node structure. That means new node will store an address. New node is not going to store the entire node. Where is the new node stored? The new node is stored in the heap. A process has code, which is the compiled code, data, which are all the constants, global variables, static variables. It has got a stack where you have the function calls going one on top of each other, and there is a heap usually growing from the top. What is a heap? It's like a gadda, right? It's a gadda. Gadde ke upar tum kuch bhi dal do. It is like that. That's literally the meaning of heap. It's a gadda. You get some memory out of your gadda, your heap, and that is where the node is stored. What is the address of that? That address is getting stored in new node. So new node has an address. उसमें पता होता है कि heap में कहाँ पे जाने पे वो node आपको मिलेगा. That's all. Is this clear?
Yes, sir.
Okay. All right. Because of some errors that can happen in malloc, because you are running out of memory, you have very less RAM, or for whatever reason. If the new node comes out to be null, then you are unable to allocate memory, and you just exit this function. I mean, you exit the entire program. That's all. Okay. You exit the entire program by calling the exit system. This is very, very rare. So let's pray that this does not happen. And in that case, new node will have the address, okay, of where the node has been allocated on the heap. Now, new node is a pointer to a structure, and you can use this notation. You can use the arrow notation for pointers to structures. What is a pointer? An address. It points to a structure. So instead of using the dot notation, you can use the dot notation on structure values. If you have a structure value, then you can use a dot notation. You can say node dot data equal to this. But here, new node is not a structure value. It is a pointer to a structure. Okay, and that is why you can use the arrow notation, and you say whatever new node is pointing to, go there and change the data part of that node and store this data. Whatever data has come, this data and this data, they are different things. This data points to this. This data is basically this data that you have sent to the function. ये न्यू नोड के अंदर जो भी पता है, जो भी एड्रेस है, उधर जाओ, वहां पे जाके तुमको एक स्ट्रक्चर मिलेगा, उसका वैल्यू जो वहां पे है, उसके अंदर जो डेटा वाला पार्ट है, उसको तुम इस डेटा से भरो, उसके अंदर जो नेक्स्ट वाला जो पॉइंटर है, एक पॉइंटर भी तो होगा ना, ये वाला पार्ट जो पॉइंटर है, उसको तुम नल कर दो. अभी हमको पता नहीं है, वी डू नॉट नो वेयर इज दैट नोड गोइंग टू पॉइंट टू. सेट इट टू नल फॉर नाउ एंड देन रिटर्न दिस न्यू नोड. न्यू नोड में क्या है? एड्रेस. मतलब ये पॉइंटर है, हमारा फंक्शन में पॉइंटर वापस करता है. दिस एंटायर थिंग इज मेकिंग सेंस टू यू? टेक सम टाइम.
Yes, sir.
Okay, all right. For some of you, you might think that I am just watering it down way more than necessary, but this is actually necessary. We need to treat this, give this much importance. Otherwise, you will get very easily confused. Okay. Insertion at the head inserts a new node at the beginning of the list. Why are we taking a double pointer here? What is a double pointer? Now, what is a pointer? It points to, it has the address of what? An integer or a struct or something like that, right? What is a pointer to a pointer? That is a double point. What do you mean by that? What is a pointer to a pointer? Now, the single pointer is also stored somewhere. Right? अगर तुम एक पॉइंटर को, तुम्हारा काम क्या है, तुम्हारे अंदर क्या है, एक एड्रेस है, वो किसी और को पॉइंट करता है, लेकिन तुम कहां पे रहते हो? तुम भी तो मेमोरी में कहीं पे रहते हो. अरे तुम्हारा भी तो कोई एड्रेस है, ठीक है? जिसके पास तुम्हारा एड्रेस है वो डबल पॉइंटर है, मतलब वो एक पॉइंटर को पॉइंट करता है ना? ये समझे कि नहीं?
Yes, sir.
तो वो डबल पॉइंटर है, मतलब एक पॉइंटर जो कि और एक पॉइंटर का एड्रेस अपने पास रखता है, ठीक है? तो वो डबल पॉइंटर. तो वो हमने हाँ बोलो.
सर, इसका यूज कैसे करेंगे? सर, डबल पॉइंटर का यूज एग्जैक्टली क्या होता है?
देखो ना, इसमें देखो तो वो पता चलता है. ठीक, ये 3 लाइन बहुत इंपॉर्टेंट है. ठीक है, यहाँ पे जो हेड है ना, हमने उसका पता नहीं लिया, उसका पता जो रखता है उसका पता लिया है. पते का पता, एड्रेस का एड्रेस. समझ रहे हो? ये हेड को जो पॉइंट करता है, हमने उसका एड्रेस लिया है. तो मैं तो यहाँ पे वो नोट पैड में करके सकता, थोड़ा टाइम लगेगा, लगने दो, कोई फर्क नहीं पड़ता, बहुत इंपॉर्टेंट है. तो यहाँ पे क्या हो रहा है, देखो, तो हमको हेड पे इंसर्ट करना है, मतलब लिंक लिस्ट के हेड पे, जहाँ पे उसका सर है, जहाँ पे उसका मुंडी है, वहां पे हमको एक नोड इंसर्ट करना है. वहां पे ऑलरेडी एक हेड है, तो क्या होगा? वहां पे ऑलरेडी एक हेड है, तो वो क्या होगा?
उसमें इंसर्ट हो जाएगा.
वो हेड सेकंड पोजीशन पे चला जाएगा.
एग्जैक्टली. तो यहाँ पे हाँ, एक लिंक लिस्ट बनाते हैं यहाँ पे. ठीक है, मान लो हमने यहाँ पे 5 को स्टोर किया, यहाँ पे 6 को स्टोर किया, फिर उसके बाद हमने 9 को स्टोर किया, और उसके बाद हमने यहाँ पे 1 को स्टोर किया. ये है हमारा लिंक लिस्ट, ठीक है। और यहाँ पे हमारा एक हेड का पॉइंटर है, ठीक है। यहाँ पे हमारा हेड कौन सा है? 5 हमारा हेड है। ये क्या है? ये बस एक पॉइंटर है जो कि किसको पॉइंट करता है? 5। ये हमारे हेड को पॉइंट कर रहा है। समझ रहे हो? ये बात सबको समझ में आई?
यस सर।
ठीक। यहां पे क्या हो रहा है? ये जो पॉइंटर है ये हेड का एड्रेस रखता है, समझ रहे हो? तो ये जो हेड हो गया, ये क्या हो गया? नोड का डबल पॉइंटर, ठीक है। ये जो हेड है ये क्या है? ये हो गया नोड का पॉइंटर। तो मैं ये क्या लिख सकता हूं? यहाँ पे इसको हमें मान लो, यहाँ पे हम इसको कोई भी एक वैल्यू ले लो, एड्रेस ऑफ ये लिस्ट, मैंने तो कुछ भी ले लो, ABC। ABC जो है ये क्या है? एड्रेस ऑफ हेड। समझ रहे? ये अभी यहाँ पे सिचुएशन है। तो जो ABC हो गया ये डबल पॉइंटर है, और जो हेड है वो सिंगल पॉइंट। ये बात सबको समझ में आई कि?
यस सर।
ये समझ में आ गई। अच्छा, अभी हमको कुछ इंसर्ट करना है, तो हम क्या करेंगे? मान लो यहाँ पे अगर इंसर्ट करना है तो हम क्या करेंगे? यहाँ पे हमारे को 7 इंसर्ट, तो एक 7 का नोड बनाएंगे, है कि नहीं? और ये 7 का नोड यहाँ पे बन गया। लेकिन अभी 5 अभी हेड नहीं रहा, अभी एक नया नोड बन गया, ठीक है। अभी एक नया नोड यहाँ पे बन गया, तो ये हेड के वैल्यू को चेंज करना पड़ेगा। हेड का वैल्यू क्या है? पहले हेड के अंदर क्या वैल्यू था? 5 जहां पे था उसका एड्रेस हेड के अंदर था, है कि नहीं? नोड नंबर 5 जहां पे था उसका जो एड्रेस है वो हेड के अंदर था। अभी ये 7 इंसर्ट करने के बाद हेड के अंदर क्या रहेगा? 7 का एड्रेस रहेगा। 7 जिस नोड में है उसका एड्रेस हेड में रहेगा। मतलब हमने हेड के अंदर क्या किया? हेड के वैल्यू को चेंज किया। लेकिन हमको सी प्रोग्रामिंग में ये पता है कि किसी के वैल्यू को अगर चेंज करना है ना, हमें उसका पता चाहिए। अगर कोई वैल्यू को तुमको चेंज करना है एक फंक्शन के अंदर, तो तुमको क्या करना है? बस वो वैल्यू भेजने से नहीं चलेगा, उसका एड्रेस भेजना पड़ेगा तुम्हें, तभी वो फंक्शन जाके उसके अंदर का वैल्यू को चेंज कर सकता है। अब मुझे कोई बताए कि हेड के अंदर जो वैल्यू था वो 5 वाले नोड का एड्रेस था। अभी यहाँ पे हेड का जो वैल्यू है वो चेंज हुआ है कि नहीं?
Yes, sir.
हाँ, और वो चेंज होके कहाँ पे पॉइंट कर रहा है? उसके अंदर जो नया एड्रेस है वो अभी ये वाले नोड का एड्रेस उसके अंदर है। तो मतलब हेड के अंदर जो वैल्यू था, जो एड्रेस था, वो हमने चेंज किया। लेकिन उसको चेंज करने के लिए हमको हेड का एड्रेस भेजना पड़ेगा, और हेड का एड्रेस कौन है? ABC, जो कि एक डबल पॉइंटर है। इसीलिए हमने वहां पे डबल पॉइंटर भेजा है। ये बहुत इंपॉर्टेंट है, ये समझना। ये समझ में आया आपको कि क्यों हमें यहां पे डबल पॉइंटर भेजा हुआ है? अभी थोड़ा सा कोड में देख लो क्या हो रहा है। हमको एक नया नोड इंसर्ट करना है। वी वांट टू इंसर्ट अ न्यू नोड, सो व्हाट वी विल डू, वी विल क्रिएट अ न्यू नोड and we will use this function that we created just before. And what does this new this function return? It returns the address of the new node, कि वो नोड हीप में कहां पे है उसका एड्रेस हमें दिया है, और वो एड्रेस हमने कहां पे स्टोर कर दिया? ये न्यू नोड के पॉइंटर में, नोड पॉइंट, ये पॉइंटर में हमने वो एड्रेस को स्टोर कर दिया। हम क्या करेंगे अभी, वो जो न्यू नोड है उसका नेक्स्ट कौन होगा? देखो ये न्यू नोड में हमारा क्या है, 7 है, 7, ठीक है। पहले के हेड में क्या था, 5 था। जो डायग्राम मैंने वहां पे करके देखा है उसमें पहले के हेड में 5 था। न्यू नोड में हमने क्या रखा, 7। लेकिन वो 7 किसको पॉइंट किया? जैसे युवराज ने बोला, वो 7 जो है वो 5 को पॉइंट करेगा, है ना, जो कि हेड का वैल्यू है। हेड का वैल्यू क्या है, हेड क्या है मुझे कोई बताए? वो डबल पॉइंटर, ठीक है। मैं फिर से उसमें जाता हूं, ये देखो, ये एबीसी मान के चलो, वहां पे जो हेड था डबल पॉइंटर, उसको हेड लिया होगा, थोड़ा सा कंफ्यूज मत होना, उसको तो एबीसी मान के चलो। ये पहले ये हेड किसको पॉइंट करता था, 5। अभी हमको हेड को पॉइंट करवाना है ना 7 को, ठीक है। तो ये एबीसी का वैल्यू क्या है?
हेड का एड्रेस।
एग्जैक्टली, वो हेड का एड्रेस है, उसके अंदर तुम्हारा हेड का एड्रेस पड़ा हुआ है, ठीक है। ये जो है ये डबल पॉइंटर है, इसके अंदर हेड का एड्रेस है। तो हमने जो नया नोड बनाया वो किसको पॉइंट करेगा, जो पुराना हेड था, है ना। और नेक्स्ट क्या है, वैसे नेक्स्ट एक पॉइंटर ही तो है। नोड के अंदर जो नेक्स्ट होता है वो भी एक पॉइंटर होता है, वो एक एड्रेस होता है। तो हमने वो एड्रेस को लेके इसमें डाल दिया। तो जो नया नोड बनेगा वो अभी पुराने हेड को पॉइंट करेगा। आई थिंक इतना तुमको क्लियर हो गया होगा, ठीक है। और इसके अंदर जो नया वैल्यू जाएगा वो क्या जाएगा, ये जो नया हेड हमने बनाया ना उसको हम उसके वैल्यू में रख देंगे। तो ये फंक्शन के बाहर हमें पता चल जाएगा कि जो नया हेड है उसका एड्रेस कहां है, जो नया हेड है उसका एड्रेस कहां है हमको पता चल जाएगा। क्यों? क्योंकि हमने उसके एड्रेस का एड्रेस यहां पे लिया हो। और अगर एड्रेस का एड्रेस तुम ले सकते हो, तुम उस एड्रेस को वहां पे बदल सकते हो। और हमने वो एड्रेस को यहां पे बदला हुआ है, जो कि मैं तुमको समझा रहा था। ये समझे? हमने एक नया नोड बनाया, इसका एड्रेस हमारे पास है, ये एड्रेस है इसीलिए हमने एरो नोटेशन यूज किया है। और ये जो नया नोड है उसका नेक्स्ट जो बनेगा, ये नया नोड में हमने 7 स्टोर कर रखा है, ये अभी 5 को पॉइंट करेगा। 5 क्या था, पुराना हेड था, जो कि अभी भी हेड का वैल्यू है ना, हेड का वैल्यू है, जो कि हेड हमारा हेड को पॉइंट, उसका जो वैल्यू है उसके अंदर हेड का एड्रेस हो, वो यहाँ पे उसके नेक्स्ट को यहाँ पे सेट कर दिया। और फिर हेड का जो नया वैल्यू है वो नया नोड हो गया, वो 7 का एड्रेस हो गया, ठीक है। आगे बढ़े, ये क्लियर है सबको?
यस सर।
इंसर्शन एट द टेल, चलो टेल में इंसर्ट करना है तो हमको नोड का हमने जो हेड का एड्रेस यहाँ पे लिया हुआ है, डेटा लिया, ठीक। पहले तो नोड बनाना है, इंसर्ट करना है तो नोड बनाना है। चलो अगर ये लिस्ट पूरा एम्प्टी है उसका मतलब क्या है, ये नल हो गया, ठीक है। हमारा जो हेड है उसका जो वैल्यू है उसके अंदर कोई वैल्यू है ही नहीं, मतलब वो नल को पॉइंट करना है, मतलब ये लिंक लिस्ट एम्प्टी है, इसके अंदर कुछ भी नहीं है। तो आपको क्या करना है, उसको इस पते में स्टोर कर देना है कि वो जो नल को पॉइंट कर रहा था अभी वो नए नोड की जो एड्रेस है उसको पॉइंट करेगा। फंक्शन के बाहर हमें पता चल जाएगा कि हाँ हाँ ये इसके अंदर तुमने ये लिस्ट एम्प्टी था और जो नया नोड बना इसका एड्रेस तुमने इसके अंदर डाल दिया। और उसको अगर चेंज करना है तो उसका एड्रेस का एड्रेस हमें लेना पड़ेगा, इसलिए डबल पॉइंटर ने लिया। अगर ऐसी बात नहीं है तो हमको क्या करना है, लिंक लिस्ट के एंड तक जाना है। तो हम क्या करेंगे, पॉइंटर यूज करेंगे, उसको कहां पे पॉइंट करवाएंगे, हेड पे, ठीक है। और ये वैल्यू ऑफ हेड, ये जो हेड वाला वेरिएबल है ये पॉइंटर का पॉइंटर है, उसका जो वैल्यू है उसके अंदर हमको हेड का एड्रेस मिल जाएगा, है ना। तो वो हमने यहाँ पे स्टोर कर लिया करंट पे। और जब तक कि करंट नेक्स्ट, करंट का नेक्स्ट क्या है? नेक्स्ट वैल्यू। जब तक वो नल नहीं हो जाता हम उसको आगे बढ़ाते रहेंगे। करंट इक्वल टू करंट का नेक्स्ट, ठीक है? तो फिर वो नेक्स्ट को पॉइंट करेंगे, ऊपर चढ़ के चेक करेंगे कि तुम्हारा जो नेक्स्ट है वो नल है क्या, नहीं है, तो चलो और एक आगे बढ़ो, और एक आगे बढ़ो। ऐसे करते 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 हम कहां तक पहुंचेंगे? जब तक कि करंट का नेक्स्ट नल नहीं हो जाता, मतलब वो टेल पे ना पहुंच जाते, क्योंकि टेल का जो नेक्स्ट होता है ना वो नल होता है, जैसे कि मैंने यहाँ पे इस डायग्राम पे समझाया हुआ है तुम्हें, ठीक है? जो टेल का जो नेक्स्ट होता है ना वो हमेशा नल होता है। तो अगर हम टेल पे आ गए तो हमारा करंट कहां पे पॉइंट करता है? टेल पे। करंट विल बी पॉइंटिंग टू टेल। सो व्हेन द करंट इज पॉइंटिंग टू टेल, व्हाट वी विल डू, करंट के नेक्स्ट को हम न्यू नोड करते हैं। अभी वो टेल को पॉइंट नहीं करेगा, अभी वो नए नोड को पॉइंट करेगा, और नया नोड पॉइंट कर रहा है नल को हमेशा। जब क्रिएट नोड करते हैं ना हम, तो उसके नेक्स्ट को हम नल पे पॉइंट कराते ही है, तो वो अभी नया टेल बन जाएगा और ये अभी टेल नहीं रहेगा। ये समझ में है सबको?
Yes, sir.
चलो मैं यहाँ पे अब इसको स्टॉप कर रहा हूँ।